Well, welcome everybody. My name's Bob Gatliff. I retired from the Geological Survey about 2.5 years ago when I was Director of Marine and Petroleum, Marine and Energy at the time. And this talk brings you a lot of pretty pictures about the geology of the sea beneath the land around Scotland. When the Scottish Geology Trust was set up, and I hope you're all members, if you're not, it's quite easy to join. The idea was to promote geology to the public and to encourage education and encourage understanding of geology. And I suggested that we should have marine geology in there, and there was some reticence that, well, you can't see it and nobody lives there, and how important is it? And I stressed at the time that, Scotland it's got a heritage of using the seas, and I think it's important that people in Scotland and indeed elsewhere look at the geodiversity and the biodiversity and know a bit about the earth beneath the sea. Now, it is quite complicated. You see that picture. Once the sea gets in the way, it's quite hard to see anything. And we have to use remote sensing and sampling and things to do it. So I'll do a bit of a history of exploration in the sea and then think about a few of the things that might go on before. So there's a lot of pretty pictures, and I should thank all my ex-colleagues in BGS. I have to give up my email when I retire, but I didn't have to give up my PowerPoint presentation. So I've got quite a lot of stuff. So here we go. So can I get rid of these pictures? Yes, I can, the thumbnails, that's better. And I can see my screen as well. So if you look at the what's going on here?
Sorry about that, I accidentally muted you. You're fine now.
Right. The brown line that you can see goes all the way around, is the edge of territorial waters around the UK. It's a bit fainter down there, I haven't strengthened that. You can see it goes off the map to the west. And this map shows the bathymetry, which is the depth of the sea. And you can see it's not smooth, it's not flat. There are all sorts of features along here and in the North Sea. Even the North Sea is not flat. And you can see some little curvy things here. And then as you go west, here the water is over 2,000 meters deep, and these features are old volcanoes that are sticking up with a relief of over 2,000 meters, so that from the base of the sea to the top of them is greater than Ben Nevis. And then as you go further out, this is the last little island in the UK, Rockall. And I hope you can see. And how did we get this bathymetry together? Well, bathymetry in the old days was collected by soundings and echo sounders on boats, and you put it all together. And this EMODnet bathymetry was put together in an EU project with all the countries of Europe. And we've put together, as part of that project, maps of the seabed, maps of the geology, and they're all joined up, and the bathymetry. And they're all available free to go and have a look at if you go to EMODnet. And there is lots of exciting geomorphology there. And we're going to have a look at some of this varied subsurface geology. And of course, there's lots going on the shelf economically: oil and gas, fishing, aquaculture, renewable energy. And in the future, there could well be CO2 storage. We could be looking at geothermal energy and perhaps one or two other things. So. Oops. So there's another map. Of course, we know more about our offshore because of the oil and gas exploration. And you can see around here all these red pipelines, and there's areas licensed, and there's lots of oil fields, primarily in the North Sea, but also to the north in west of Shetland. And then I've named on this map some of those features that you can see to the left in the Rockall Trough and Rosemary Bank and Anton Dawn and things. And how are we going to find out about the geology of those? Well, when North Sea oil exploration started, the government decided that we should have geological maps and understand the shelf so that we could plan what was going on. So in the late 1960s, early 1970s, a few projects were started. And one of the easiest ways to look at the structure beneath the sea is to use gravity data, which you can collect from satellite or from ships, or magnetic data. And the two maps there, the one on the left is gravity and the one on the right is magnetic data. And I'm just going to highlight a few things. Where it's blue, it's low gravity, and that's either because it's very deep water or there's thick sediments that are low density. And where it's high, you've got hard rocks. So underneath the oceans, you've got a lot of basalts and things. And see these little red ones? Those are these volcanoes within the deep water of the Rockall Trough. And in the North Sea, there's lots of sediments and things. And then see it to the west of Scotland, it's all very, very complicated. And the magnetic data is quite interesting. I hope you can see that there's an area in the oceans with lots of parallel lines, and an area on the continent where you don't see that. And if you just draw a line somewhere between the two, that's actually the continental ocean boundary. Scottish and British waters come to about here. They don't actually reach the ocean floor, which is in international waters. And the third way that we can find geology beneath the sea is to use seismic data. And this line across the bottom is one taken across. It shows up better on the gravity data. See that line there? That's a ridge called the Wyville-Thomson Ridge, which is this feature here. And this line is going through across here into the Rockall Trough to the south and into the Ferryshetland Basin Trough to the north. And this is a beautiful folded structure. This is actually because it's exposed at the top. If you take samples here, and we've drilled some little holes, there are lavas of Eocene age at the seabed here, and they've been folded. And I hope you can see there's an unconformity about here, and these beds are flat on the top, and that's somewhere within the Oligocene Miocene. So these are very late big folds that you don't see on land in Scotland. Completely different geology that we're seeing offshore. It's really quite exciting. At the moment, we think these are caused to do with changes in the angle and rates of ocean spreading and sort of compression between Europe and the Atlantic Ocean. So that was quite a good. And the other part that we did, well, we actually take samples of the seabed. And this map looks really quite interesting. It's got lots going on. The yellows are where there's sand at the seabed, and the greens are where there's mud at the seabed, and the purpley colours are where there are conglomerates and gravels at the seabed, and the black areas are where there's rock at the seabed. So it does look as though primarily there are sediments on the seabed, but it's quite varied. When you zoom in and see what we actually collected, and looking in the Forth where we're sitting now, you can see it looks quite complicated. You notice the contours underneath the map don't match the lines that we've done, and it's a really complicated story. And then if you zoom in even further, you'll find that we've probably only got one sample in each of the different areas, and it really is a reconnaissance map. And it was very difficult to do more until in about the turn of the century, there was a big change in how you could map the seabed. And instead of single beam echo sounders that you might have on your boat, you can do multi-beam echo sounders. And this map underneath the Forth bridges shows the seabed in much more detail. And the boat here is the Geological Survey's first survey vessel with this technique, the equipment on it, which is lowered down underneath through the bottom. It's called Multibeam. And it maps a swath as you go along. And the swath is about 8 or 9 times wider than the water depth. So you can go backwards and forwards and build up a big picture. And you can see all sorts of features start turning up. These are some kind of moraine they've been interpreting. You can see rock ridges. And then if you tie in seismic data, you can get a good idea. So if we could use that all over the place, we could have a whole new set of maps with much more detailed geomorphology. And this is one area that we've done. So the map on the left is the old published Seabed Geology Map. Then we can collect multi-beam data, and you can see it's much more detailed. Part of the data you get is the bathymetry, which is this in colour. And then you can also look at the shape of the reflections that come back. And if it's bouncing off a hard rock surface, you get one kind of shape back. And if it's bouncing off very soft mud, you get much less return. And then you can predict what kind of rock that's there. And you can end up with a much more detailed map. So that was rather quite exciting. And lots of countries set about national seabed mapping projects. Ireland have done all their waters. In the Gulf of Mexico, the oil companies did quite a lot because they'd realized that on this data, they could see areas where gas was escaping and they could use that as a tool for exploring for gas or oil. And Australia has done masses of theirs primarily for habitat mapping, and the Netherlands have done all of theirs primarily looking for sand and gravel, which they can dredge and support their keeping the sea out of the Netherlands. And the picture I shows here is one that Canada did very early on. And the brown colours, they've analysed the data and I think those are the best areas where scallops grow. And they used this to try and stop fishing boats damaging areas which they didn't need to go to, and saving time by cutting the number of trawls that they had to do. And you can see, so before, the fishermen were going all over the place, but now they can concentrate in areas where they know there are scallops. They can see where there are scallops are. So they reduce damage to the seabed. They can control the numbers that are taken. So there are lots of ideas as to why they do it. Unfortunately, in Britain, we had a few goes at trying to have a national seabed survey, but we didn't manage it. You can see from this map that quite a lot of it has been done already. And this is quite exciting over the years that we've managed to work together with different groups. So Marine Scotland have one of these systems. SAMS in Oban have done quite a bit around the islands of Mull and round there. CFAS, which is the equivalent of Marine Scotland in England, they've also got one. But the largest amount is collected for our civil hydrography program because they want really good charts for making it safe for ships. So, and all those organizations have got together and share all their data. And out in the North Sea in the middle, there are lots of patches now that the wind farm companies have done. They haven't all been released yet. But gradually we're building up a case that when you're right out here in the deep water, it's a bit more difficult because the resolution you get from the surface is lower because the swaths are less dense. So you can use things like this yellow thing here, which is an ROV, remote operated vehicle, worked by the National Oceanography Centre in Southampton. And they can sail that deep. And one of the aspects of that is we've now got this new map on the right, which shows that there is actually quite a lot more bedrock near the seabed, which is really important for understanding biodiversity and habitats and things like that. And we've now got a lot of data to try and set up a network of marine protected areas. And Marine Scotland and the Joint Nature Conservation Council, JNCC, have set up all these areas around Scotland now, which have some protection from commercial operations or damage. And I'm going to show you some pictures from some of these, and they're quite a range. Huntington Bank is the furthest out west that we're going to go. This is Rockall Trough. I'll show you some from Rosemary Bank, which is one of these big volcanoes. You may have heard of the Darwin Mounds, which are cold water corals. In the Ferryshetland Basin, there's some very interesting geomorphological features, and there's something different up here to show you. And in Mingulay, it's one of the islands of the Outer Hebrides, between the mainland and Mingulay, there is a ridge of volcanic rocks, and on top of that, various cold water corals have grown. And then there's glacial features and all sorts of things. So it's really quite exciting. So there's a whole load of habitats, a whole load of biodiversity, and the range of water depths. You know, we have a greater range of depth than we've got height on land, and it's a bigger area. So let's go and have a look at some of the, yes, and some of them are protected for geology, some of them are protected for biodiversity, and some of them are historic MPAs, where there have been what do you call it, wrecks and things like that of historical importance. And there's this area in around here where they're trying to protect the sand eels to provide food for seabirds. So let's go and have a look at some of these and see what it is. So first of all, what influences the seabed geomorphology? And I've got a few things here. Of course, the ice covered a lot of the shelf. That was at maximum of the last ice age, about 27 kilometers. And we can now see the evidence on the seabed, and I'll show you some of that. And of course, it gradually reduced as you get nearer and nearer till it was just on shore. And then following, at the same time, there was this big transgression. So the Dogger Bank was all land, and gradually as sea level rise, Scotland began to take shape. And then there are rock platforms like this. Anyone recognize where these are? This is Rum and Canna and Muck and Egg. And you can see there's the smooth areas tend to be sediments, and the really coarse areas tend to be rocks. And on top of that, a long time ago, these chaps, Kenyon and Cooper, did assessments of the currents, the tidal currents and things around the shelf. So they all interact, and you can get very interesting features. I hope you all see this. The land is up here, and this is Loch Erebol on the north coast of Scotland. And the sides, all this has tumbled into this deep water bit in the middle. And the landslides are quite common features around the coast of Scotland. Pockmarks are quite common. Ooh, I've gone wrong. On the seabed in the North Sea, where gas has escaped naturally from deep in the North Sea and has come to the surface, bubbles up there, few tens of meters or sometimes bigger across, and they can be 10, 20 meters deep. Some are still active, and they have really interesting habitats in there where animals grow that like the methane. This is a beautiful field of drumlins. Of course, mobile sediments. This is near an island and a point, and you can see big sandbars. And then I think this is from the North and North Sea. These lines in here, we think of iceberg plough marks as the ice was melting. And, the one bottom at the left here, Loch Broom, we'll see these features in here. This is in Loch Broom. These are retreat moraines. So there was a big glacier going down through Loch Broom, and as the ice retreated, it left a series of moraines. And they're much better preserved in the loch than they are on land. So once the sea has covered them up, they've been preserved quite well. The map at the top left, this is a phenomenal feature, isn't it, this one? This is actually not multi-beam data. This is single beam data that the fishing industry, they all have single beam echo sounders on their ships, and they've collected all the data and combined it together, and they built up a bathymetry themselves. And this is interpreted as the route of a fast moving ice stream or glacier. And these are all moraines at the end, and these are more retreat moraines. And it's all going from the south to north to the east of Shetland. And the map at the bottom here shows all the glacial features that have been mapped around the Scottish coast. This is in the Ferryshetland basin to the west of Shetland. This again is not multi-beam data, but this is data from oil and gas exploration seismic data. And you take the first returns from the seabed, and I hope you can see these beautiful linear channels that are going down from shallow water near Shetland, down the slope into the basin at the bottom, where they're depositing all these sand fans at the bottom. And this one is on the slope further along. This is a scarp, and you can see the scale, 10 meters, and all this material has slumped down the slope. So this is a submarine landslide. Both these areas have been protected by JNCC and Marine Scotland as marine protected areas. And I thought you'd like to see some of the rock platforms around. This is Arden American. Well, you know, the ring dikes and things, and there's a little fault that you can see on shore, and offshore you can follow it all the way along. And we think this is a continuation of the Camasunary fault, which you can see in Skye. And the hard, shallower bits are Rockall basalt platforms, and the smooth, slightly deeper bits are sediment. And then the deeper bits here, I think this is called the Muck Deep, the deepest point on the shelf. There's been erosion by ice, and there's some Torridonian sandstones are here and things. And this little one, this map here, I hope you can see dunes in here migrating, and this is between Jura and Scarborough. The Corryvreckan was one of the biggest tidal currents in the world going through here, and you can see all rock is scoured at both sides, and the sediment is moving quite rapidly. We showed you one picture of submarine landslides already. Here's another one in the Sound of Mull with a whole series of landslides. And what are they caused by? Well, we're not quite sure, but just unstable sediments on both sides, and they're slumping down. But they're a hazard. In some of the sea locks in Norway, there have been occasional big rock slides which have caused local tsunamis, and these can damage infrastructure in the sea locks. So mapping where those are is quite important, and assessing the risk. It could be caused by shallow gas disturbing things, all sorts of things that could do it. Right out on the Hatton Bank, this is a seismic line that BGS collected. This is the seabed here, and this is the edge of the Hatton Bank. So this is about several 600 meters of water, and then there's a clear young package of sediments, and then there's a big unconformity here with other rocks dipping down. But this unusual feature on the edge turns out to have lots of cold water corals on it, and this is a reef, and it grows because currents are coming up and along the edge of the margin, and you can grow these fantastic features. This is also preserved, and there's quite a bit of multibeam data out in this area, and funnily enough it was collected by the Spanish fishing research group, because this is an area where the Spanish trawlers come and fish rather than UK ones, and it's very interesting that they've taken the lead in this area, which is they're quite entitled to right out beyond 200 nautical miles. But it's fascinating that we're trying now to preserve these things. These are 4 pictures from the JNCC website of a video and pictures taken on the top and the sides of Rosemary Bank, which is one of these big old Cretaceous volcanoes that has grown in the Rockall Trough, and fascinating areas. This is also in an NPA. And the Mingulay cold water reefs, these are fascinating. So these little lumps here, when you go in, they're all made out of this stuff, and then they form where there's currents going through and they're on a ridge, so that the corals can get their food. There's continuous motion of water, and we found that as you go off these, there's lots of rubble down here. And I was on a ship many years ago now, trying to do things further west, and it was really rough. So we sheltered within the Sea of Hebrides, and we managed to core through the rubble. We didn't go anywhere where there was live, but we cored through the rubble and got 6 meters of coral debris, which has been used on a PhD at SAMS to try and work out the history of what's going on. Is there a continuous age? Did they grow in peaks? But it does seem that they form very quickly after the last ice age, and they're pretty continuous. It's working. So beautiful features. I think I've got just 2 more. The Darwin Mounds, you may have read up in the north of the Rockall Trough in very deep water, about 1,500 meters. These are very small, and you can't really see them on this multibeam. You need better multibeam to do it, but you can see the pictures that you can get. And the seismic line on this side here, in the northeast Ferryshetland Basin, which is the largest marine protected area in the UK, is right in the north of Scottish waters. And there's all sorts of sponges and all sorts of things that they found. But one of the unique things for the UK is these features here on the seabed. And we've called these the pilot whale diapirs. I don't know who named them, but you can see underneath, this is the top of the Eocene basalts, a big fold that had formed sometime around the Oligocene Miocene. And clays on the top have been squeezed, and they're probably overpressured with water, and they've risen up, and you get mud diapirs on the seabed. So they form a unique habitat as well. And I'm pleased to say that they are also protected as an MPA. And the last one that I wanted to show you was something that Marine Scotland and scientists in Scotland did first. They went out, this is the little island of Rockall, and this is on Rockall Bank to the western side. And they found these shells, which it turns out rather like methane to grow. And the theory is that the methane may have formed naturally down here and percolated up this unconformity here with fairly young sediments on the top. And they were found just about here. And I just want to highlight one more thing. On this seismic line, can you see these little faults in here? On the plan view, which I haven't got here, they're like polygonal structures, and they're sort of fractures that are letting fluids up, and we're not quite sure why they form, but it could be due to water escape and reactions in the clay minerals that have caused a change in volume. So that's a really quick view of quite a lot of different things that you can see on the seabed, and I think it's probably really useful to try and get that message out somehow, that there are these fantastic different environments and geomorphology and habitats. And I just wanted to finish up with a few minutes on what next and what does this all mean for future developments. The map in the middle, the light blue areas are where we've already got wind farms being built or active. The dark blue areas are where there's leasing for other wind farms. Some of them are in areas with rock at the seabed, which with present technologies is not considered a good idea, because you put big turbines in rock, the stresses quite often fracture the rock or could fracture the rock. So all the ones that have been built so far have been built in thick soft sediments with deep piled foundations. But there are people now working the idea of having floating wind turbines where you anchor on big platforms and ships, in which case you could put them where there's rock. And the map on the right is all different locations for where we could put CO2 in the ground in old oil and gas fields or in the main aquifers of which the oil and gas fields lie. And it's amazing, I find, that we've still not injected CO2 into the North Sea on a commercial basis, or even on a trial basis. I think it was maybe 20 years ago that BP had a field called Miller that they developed so that that CO2 could be stored in the field after use. And there was no encouragement through the fiscal system at all for anyone to do it. And then more recently, Shell had a gas field called Goldeneye, which is offshore from Peterhead, which was just right for doing a test. And there was money in a project proposal funded by the government to do a trial there, which in 2008 was scrapped with the banking crisis. So we still haven't done it, but I still think there's potential to use some of that infrastructure to store CO2. Other things that we should be doing, of course, tidal and wave energy. If you look, there are passageways through here, the Pentland Firth, and ones along here. We have in Britain about half the tidal energy of Europe, and in Scotland we've got about half the British tidal energy. And there are some experiments. They do, of course, need to know the shape of the channels, and it's useful to know what the rocks are made of. Wave energy is a bit less predictable, but on the west coast there are big waves, and no one seems to have done too much about that yet. But we do need to understand the geology if we're going to build wave turbines. There's lots of, well, there is some potential. I don't understand this. I'm not going to talk too much about it, of bio-CO2 storage in growing seaweed and things, and particularly merle, which is a coralline algae, and that's got calcium carbonate in. If you could get that to grow more, you might be able to store CO2. And of course, we can reuse oil and gas data to do all these things, and we could not only store CO2, but we could perhaps make hydrogen from excess energy from the wind turbines, and you might need to store that. And of course, there's geothermal energy in the deep wells where the oil comes from. There's lots of aquifers, and they're up to 200 degrees centigrade. And so there is a ready source of heat. Other things that we need to think about with sea level rising are sea defences. So with real good knowledge of the coastal geomorphology and whether there's aggregate or semi-natural ways of making sea defences better, we should be looking at that. And of course, with our multi-beams and better understanding of habitats, we could perhaps do better management of fishing and aquaculture. So there's a lot to do, and I'm going to finish after a couple more slides with just one thought on mineral explanation. But the oil and gas authorities based in Aberdeen have been looking at what they can do post oil and gas industry or just in the closing gases. And they've come up with these concepts. One is electrification of the production of oil and gas. So you have a wind turbine and you take the electricity rather than burning gas to make the electric. You could use the gas directly and on the platform and either burn it there and inject the CO2 and convert it to energy straight away, or you can generate hydrogen from wind turbines and either store that or take it to shore. And likewise, we can bring CO2 from onshore and store it offshore. So there's lots of things that we could do. They came up with this phenomenal idea, excuse me, of building an island, which you could do it all together and it becomes a kind of energy hub. And they've got three of those ideas, actually building a big island, which I think is probably far too expensive, or maybe using an existing island, you know, Shetland or something like that, and having a hub where they can do all these things, or actually using repurposing oil and gas platforms. You know, gravity ones are not rusting away, and they could be used for longer than the oil and gas. So there's some quite interesting things that might happen in the future. And I'm just going to finish with one last slide and just highlight that this is international waters, but it's close. And there's the active spreading centre through Iceland and coming out the other side and then going up here. And all along parts of this, there are black smokers and mineral deposits. And they're not that far from Scotland. I mean, we haven't found any active ones there. But Norway has got an active research programme looking at mineral deposits in Norway. And further south, lots of countries have got licenses from the International Seabed Authority to look at deposits not on active black smokers, but near them. Britain, of course, is being left behind. They've not got any big licenses like that. We have been doing research, but it's expensive and it's nothing. But just thinking that if it did take off, I think it's really quite important that we keep our border with Iceland and the Faroes around so that we do have direct access to this area away from Iceland that could be a source of minerals, and it could also, of course, be a source of geothermal energy. So on that little point, very speculative whether that would happen in this area. I shall throw it open for questions, but I hope I've managed to show you that there is a phenomenal range of geology offshore, which is, I'm sure, matches, if not exceeds, the variation that we've got onshore.